If you haven't finished the video, you're going to have to. It's kind of on you. You'll be able to skip through some stuff after today, I bet you, but there's a few things that I'm not going to do in class that are on the video. So you do need to finish watching, especially the stuff, well, should be about 2/3 of the way through it. There's a couple examples that I'm not going to do today because I don't think, unless I go through the other stuff faster, because I want to give you a little time to work and get some questions answered also. Okay. So here's how we could look at this. Quick little review of some of the main topics on the video. So everybody, please click your Chromebooks all the way closed. Get your focus up here. The topic of the day is solving absolute value equations. That's what 1.4 is about. One good way to think about understanding the pattern that we use to solve absolute value equations is to use a graph of an absolute value function. So this is what an absolute value function looks like. If we graph the function p of x, we could just call it y if we wanted. We'll use function notation though. P of x equals the absolute value of x. It just looks like this. That's the shape of an absolute value graph. It's a V with the vertex at the origin. The right leg of the V just goes forever. And so I'll put an arrow on this, how about? Just to indicate that it goes forever. The slope of the right-hand leg is 1. So I go over 1 and up 1, over 2 and up 2, etc. The left leg of the V has a slope of -1, and it just goes on forever. Okay? Here's how we can use that. There's a little trick. I want to show you this little trick here. So I can't remember if I showed this. I don't think I've showed this to you this year yet. I thought I had. Guess I didn't. All right, that's okay. So I'm going to pull up Desmos. Okay, let's just say we want to solve the equation. How about the square root of x is equal to x minus 2. You guys know how to solve that. That's not something that we won't talk about that until the very end of the year, how to solve equations like that. So you wouldn't even know how to do it. But you can solve any equation using graphing technology. If you have a graphing utility, it could be a TI-84 graphing calculator, or it could be Desmos graphing. There's a trick that always works. I want to show that to you. Okay, all you have to do with this trick, it's a pretty tricky trick. All you have to do is graph the function that's on the left side of the equation. So the function on the left of the equal sign is just the square root of x, right? So I'm just going to graph the function. I'll just call it f of x. So f of x, I could call it y if I wanted to. F of x equals the square root of x. And there it is, right? That's what a square root graph looks like. It starts at the origin. It kind of just moves up and over to the right. And then I'm going to graph on the next row down, I'm going to graph the function x minus 2. So I'll just call that g of x. Could call it y if I wanted to, but it's better to use function notation, and you'll see why a little later when I give you another example of a way we can use Desmos. Function notation always works a little better for some reasons you'll discover a little bit later. Okay, so look, I've graphed the function on the left and the function on the right. Can anybody tell me how I could use that graph to solve the equation? Where on the graph would I be able to find the solution? What do you think? What do you think, CJ? Yeah, it's where the curves intersect. Look what happens if I choose the point. And on Desmos, all you have to do is just click, somewhere, click on either one of the two graphs, and then it kind of highlights all the interesting points in gray. Well, I'm going to click on that point. Look, the coordinates are 4, 2. Okay, so let's take a picture of that. So there's the picture that goes with solving that equation. So the equation is asking me for the value of x that's going to make this equation true. What does that ordered pair tell me? What do the 4 and the 2 represent? X and y, right? Those are just the coordinates of the point where the graphs intersect. Everybody agree? That point of intersection, if I start at the origin, it's over 4 in the x direction and up 2 in the y direction, right? But I don't really care about the y. All I care about in my equation up here is the x value. So what is the solution? You guys tell me, what's the value of x where the blue and the equals the red? 4. That's it. Everybody see that? So there's the solution. The solution to that equation is just x equals 4, and we get it from right there. How cool is that? It works every time. If you graph whatever's to the left of the equal sign on one line, whatever's to the right of the equal sign on another line in Desmos or in the TI-84, and you just find the points of intersection, that's giving you all of the solutions to that equation every time. Pretty good stuff. Okay, we're going to use that here. Okay, so we want to solve the equation. I'm using u's instead of x's, and you'll see why in a little bit. But I can do that, right? There's nothing special about x. I could use any variable I want to. We just usually use x, right? But we'll use u this time. So I want to know, where is the absolute value of u equal to a, where a is just going to be some number. Okay, now how come I'm putting a there instead of a specific number? Because I want this to work for every case. I want this to be general, where we could choose a to be any number we want when we're done and plug that number in and it would work. See what I'm saying? I want to be as general as I can. If I want to solve this graphically, what am I going to do? Well, aren't I just going to use the trick I just did? I'm going to graph y equals the absolute value of u. That's one graph. And I'm going to graph y equals a. That's another graph. And look for the points of intersection, right? That always works, right? Well, what is y equals the absolute value of u? What does an absolute value graph look like? What's that? But the graph, what did it look like? We just looked at it a little bit ago. Yeah, it was a V, wasn't it? Right? It was a V shape. Okay, so there's the graph of y equals the absolute value of u. It's just a V-shaped graph, vertex at the origin, slope of 1, slope of -1, right? And what about the line y equals a? If a is a constant, meaning it's just a number, if I graph like y equals 10, you guys remember that from Algebra 1, right? That's just a horizontal line where all the y coordinates are 10, right? It's just going to cut through the y-axis at 10, and it's a horizontal line. So the line y equals a is just going to cut through the y-axis at a, whatever that is, whatever number that is. The points of intersection, then, wouldn't you agree, if the y value is a here, right, and the slope is 1, don't I have to go over as far as I go up? So wouldn't the x coordinate, or the u coordinate in this case, also be a? And if I go back in this direction, again, if the height is a, if that's the y coordinate, I'd have to go backwards a to go up a on the v. Agreed? So the solutions then would just be the x coordinates, which would be -a and +a. Okay? So the solution to the equation, absolute value of u equals a, if we only focus on just the x coordinates, it would be there and there, right? If I just project those down onto the x-axis, I don't care about the y value. And those would be the solutions, -a and +a. So here's our pattern. It's really simple. The pattern is, if we have the absolute value of something, call it u, is equal to some number a, then the solutions are always either u equals -a, or, that's our symbol, just our fancy math symbol for or u equals +a every time. That's how we solve absolute value equations. So let's try this. What if we have something like this? Okay. So I've got 4 times the absolute value of negative 2x minus 6 minus 2 equals 38. That looks much harder, but I'm telling you, it's not really that much harder. What do we do here? Well, our first step is we always want to isolate the absolute value. We can't touch anything inside the absolute values. It's totally off limits, right? And so one way to do that is just to ignore it. So I'm just going to do this. I'm just going to cover up everything that's inside the absolute values with a U, right? How come? Well, because we called it U here, right? And we can't look. We can't even do anything to what's inside anyway, so it's off limits. Let's just call it U. It looks easier to solve. So the first thing I want to do is I want to get that absolute value of U by itself. What are the 2 steps to isolate the absolute value? Give me one of them, Chris.
Add 2 on both sides.
Okay, I'm going to add 2. That's the first step, right? I'm going to add 2 to both sides. So we start off with that. If I add 2 to both sides, I get that. Somebody else, what's the next step? Go ahead. Divide by 4. If I divide each side by 4, then I get the absolute value isolated on the left side. On the right side, 40 divided by 4 is just 10, right? Okay, so now we just follow our pattern. Whatever's inside the absolute values is either going to be equal to negative 10 or it's going to be equal to positive 10, right? Everybody agree? Except this time it wasn't just a U, was it? What's inside was actually a negative 2x minus 6, right? But nothing changes until we get all the way down here, right? It's not until we get to this point right here where we actually are setting up these 2 equations that we begin to work with what's inside the absolute value. Now that we've gotten rid of the absolute value, we traded the absolute value equation for 2 regular equations. Now we can solve both of those, just like we normally would. But until that point, everything inside the absolute value bars, everything inside the absolute value bars is off limits, right? I can't touch anything inside the absolute value bars until the absolute value bars are gone. Everybody get that? Okay, give me thumbs on this. Okay, I mean, we just probably got to practice a little bit, right? But I can't touch anything in there until I get to this point where I've isolated the absolute value, and then whatever's inside, I'm setting equal to the positive or setting it equal to the negative number. And then I just solve, right? Well, what am I going to do to solve? That's no big deal. Aren't I, to isolate the x, aren't I just going to add 6 to both sides and divide by negative 2? That's going to give me 2 over here. What about on this side? I'm going to add 6, divide by 2, and my 2 solutions are 2 or negative 8. How could I check to see if I get them right?
Plug them back in.
Plug them in. I'm going to plug them into the original inequality and see if they work. Okay? Everybody good? All right, let's try one of those together. Okay, so here's one. This is like one of the harder ones on the assignment. Let's try this. So I got to solve this absolute value equation. Okay, now don't say anything out loud. I want everybody to think about what we're going to do here. What's the first part of the solution look like? What's my strategy? Go ahead. Okay, add 1 and then what? Divide by 6. Perfect. Okay, and the reason I'm doing that is I'm trying to isolate. Whoops. I'm trying to isolate that whole absolute value, right? So everything inside the red bubble, I got to get that red bubble by itself. To do that, I'm going to add 1 to both sides. And that's going to give me 6 times my absolute value equals 36. I'm going to divide each side through by 6. And then I got it, right? Then I've got my absolute value by itself equals 6. Everybody agree? Okay, what's inside the absolute value is a 6y minus 6. Okay, I'm going to write this one Make this blue. You'll see why. Okay, now what? I isolated the absolute value. Now what do I do? I can't do that because I can't do any algebra because I've still got absolute value bars there. I got to get rid of them before I can do anything.
Take out absolute value bars
Okay, but I mean, close. Okay, yeah, now is when I'm going to do my pattern, right? As soon as I get the isolated absolute value, that's where I've got my pattern. If I have an absolute value that's isolated equal to a number, then whatever's inside the absolute value either equals the positive number outside or whatever's inside equals the negative number. So once I get the absolute value isolated, then what's inside, which is 6y minus 6. Everybody agree? So there's my OR symbol. So either 6y minus 6, that's what's inside, is equal to, somebody who hasn't answered yet, give me one possible thing that it's equal to. Negative 6. Okay, good. So either what's inside equals negative 6 or it equals positive 6. And then I just solve those two. Pretty good? Okay. I want to point one more thing out here. In this example right here that we did, notice that I had an absolute value of a negative 2x minus 6. One thing that people always want to do is they want to get rid of those negative signs because it's inside an absolute value. And I get why they do that. They do that because the absolute value of negative 5 is equal to positive 5. Okay, but look, this is an absolute value equation that's got x's in it. We don't want to get rid of those negatives because it's going to change the answers. We want to find the values of x that I could plug into this equation exactly as it's written and make it true. I'll show you what I mean by that. What are our solutions? Let's just try one of these. What if we plug in x equals 2? Okay, if I plug in x equals 2, okay, so we're going to check the solution. So what's that going to do? If I plug that in, I get 4 times the absolute value of negative 2 times 2 minus 2. Is that equal to 38? Let's see. What's negative 2 times 2? Negative 4 minus 6? Negative 10. So I get 4 times the absolute value of negative 10 minus 2. Is that equal to 38? What's the absolute value of negative 10? 10. 4 times 10 is 40. 40 minus 2. It works. Okay, would it have worked if I had tried to plug 2 in up here and I didn't have the negative signs? Wouldn't have worked. Would have given me a different answer. See my point? When we're solving an absolute value equation with variables in it, I can't touch anything inside the absolute values, period. Okay? All right. Okay, what about one like this? What's different? Yeah, there's x's on both sides. Okay? It looks like it's going to be really hard. Well, it's not that much harder. It's maybe a tiny bit harder. We use the same rules. Do I have an isolated absolute value there? I do, right? It's already isolated, so I don't even have to do anything to isolate it. We're already there. I'm just going to follow the same rules that I had before. Okay, what's inside is x minus 4. What's outside is 5x plus 12. So what are my two equations going to look like then? Whatever's inside, which is x minus 4, is either equal to what or what? Okay, so it's either equal to the positive, what's outside. So either it equals 5x plus 12, or it equals negative what's outside. So I've got to put it all in parentheses then. It's equal to negative the quantity 5x minus 12. And now I just solve them both and see what I get. Okay. Over here, which direction should I push the x's? To the right. So I'll subtract x from both sides. And that's going to give me negative 4 equals 4x plus 12. Now what? Got to isolate the x. What are the two steps in order to isolate that x? Subtract 12 and then divide by 4. Okay, good. So we subtract 12. Those guys go away. I get 4x equals negative 16. You told me divide by 4. That's correct. And so I get the solution x equals negative 4, right? How about over here? Let's try this one. Okay, so what about this one? If I distribute the negative, I get x minus 4 equals negative 5x plus 12. Everybody agree? Okay, where am I pushing the x's? I could. Why might pushing them left be a little better? What do you think, Jasmine? Oh, in the original one. Yeah, you're right. I wrote it down wrong, didn't I? That was supposed to be a plus there. If I distribute the negative, that makes that a minus, doesn't it? Yeah, good. Okay, where am I pushing the x's? Pushing them left, how come? I don't want a negative number of them. I don't want a positive coefficient. So we'll go plus 5x. And that gives me 6x minus 4 equals negative 12. Last two steps in order. There you go. So add 4. So I get 6x equals negative 8. And then you said divide by 6. That's correct. And so the other solution I get is those x's or the 6's cancel. X equals negative 8, 6. What's that reduced to? Negative 4/3. Okay, so it's not that much harder, but there's one more thing you got to take into account here. There's a rule with this. Okay, here I'm going to put this in a box. It's such an important rule. When you have variables outside the absolute value bars, if that ever happens, and look, we do right there, right? We have an x outside of the absolute value, then you must check for extraneous solutions. And extraneous is just another fancy, that just means, that's just a math word for false solutions. Okay? So we'd have to check both of these. We have to plug negative 4 back in and negative 4/3. Okay, well, we could do that, but I'm going to show you a technology shortcut for doing that. That's very helpful. Okay? So on Desmos, it doesn't even have to be Desmos graphing. It can just be Desmos scientific. Graphing works fine too. But I've got the solutions negative 4 and negative 4/3, right? So Okay, here's what you do. So just watch this closely. Same kind of thing. I'm going to set up a function for the left and a function for the right. So I'm going to call the left, I'll just call it f of x. And it needs to be function notation. You'll see why. So I've got f of x equals absolute value. So where's the absolute value? There's the button for it right there. Everybody see that? Or if I want to, I can just use, if you look on a keyboard, right above the backslash, above enter, if I hit shift, it just gives me a vertical bar, which Desmos knows means absolute value bars. So I've got the absolute value of x minus 4. Okay, there's f of x. I'm going to set g of x equal to the right side. So g of x equals 5x plus 12. Okay, here's all I have to do. If I want to check negative 4, to see if it gives me, if it makes the equation true, aren't I just plugging negative 4 into the left side and negative 4 into the right side and see if I get the same thing? Right? Everybody agree? Okay, so let's do that. I can just do f of negative 4, and look what it gives me. It tells me it's equal to 8. Okay, I can make this a little narrower. We don't have to have it so wide. Okay. I'm going to plug negative 4 into g. So I do g of negative 4. And now every place I used to have an x, it's plugging in a negative 4. And look what happens. I get, when I plug negative 4 into the left side of the absolute value equation, I get positive 8. When I plug it into the right side, I get negative 8. So is negative 4 a solution? What do you think? If I plug negative 4 in to this, and here we can just, how about if we just look at this one? We can do this one manually, and then we'll connect it to this Desmos. Right? If I plug in x equals negative 4, I get the absolute value of negative 4 minus 4 is equal to 5 times negative 4 plus 12. Well, that just gives me the absolute value of negative 8. That's 8. 5 times negative 4 is negative 20 plus 12 is negative 8. That's not true, right? That's what Desmos told us. Desmos told us that when I plug the value into the left side, I get 8. Right side, I get negative 8. You see how this did the same thing? Give me thumbs on this. Okay? Because this is going to save you a lot of time. So I'm going to take a picture of this for our notes. Okay, so that's telling me, if I scoot down, so that part right there, look what that's telling me. That's telling me that negative 4 is that's an extraneous solution. It's not a real solution. It didn't work. So I crossed that one out. Okay, let's try the other one. Let's try negative 4/3. All I've got to do is go back to Desmos, and I can use the same template I was just using. Only now, instead of negative 4, I'm just going to use negative 4/3. Look what happens. Now, when I see that little button there, by the way, in Desmos, I can convert that to a fraction, both of those. When I plug negative 4/3 into the left side, which is f, and the right side, which is g, I get the same thing on both sides. So you tell me, thumbs up for yes, thumbs down for no. Is negative 4/3 a solution? Thumbs up for yeah, it is, isn't it? It gives me the same thing on both sides of the equation, so the equation is true. Okay? Okay, so what's that telling me? Oh, darn it, I didn't get the whole thing. Shoot. Got to go back. There we go. Okay, so this time, because I get the same thing out, right, this part right here, whoops. That means that one does check out, it works. So only get one solution. Okay, we good? Think so? Okay. When are we out of here? 42. Oh man, I'm not giving you much time. Okay, so let's look at just, being as there's not much time, I'm going to go ahead and look at, so you don't have to watch any of the video probably if you just watch this one example. Probably you're good. So what about this one? You tell me, what are the steps here to solve this equation? Somebody who hasn't answered yet. How about somebody be brave, hasn't answered yet? What do you think? Yeah, Isabel. Add 1 and then what? Divide by 3. Okay, good. So if we do that, if I add 1, and the reason I'm doing that is because whatever's inside, you know, it's just off limits. We'll just cover it up. If I add 1, so that's going to give me 3 times my absolute value equals -6. Then we divide by 3, and I get it. I get my isolated absolute value is equal to -2. Okay, I could move this out of the way if I want to, and I know that what's inside is 2x minus 1. But does it even matter? Oh, well, you get the idea. Does it even matter? What's wrong with that? Yeah, what's wrong with that? Can an absolute value ever output a number that's negative? It can't, right? So when you see something like this, where when I isolate the absolute value, when I get a negative number out here, that's impossible, right? Which means there's no solutions.